What we're about to do here is we're going to square a binomial, and this is not on the factoring binomial sheet because we're not factoring, we're squaring. All right, this is simplifying. If you wanted to put it on maybe on this box in your sheet there, the example 4 box, there's a shortcut for squaring a binomial. It looks like this. This will either make sense to you or not. If it doesn't, you can go back to just old-fashioned distributed property like we did last chapter. Okay. The advantage to doing it this way is this structure happens so many times in math, it just saves you a ton of time. This is a time saver if it makes sense. If it doesn't make sense immediately, but you kind of have a basic idea of it, I'd practice it a little bit until it makes sense, and then you'll be good to go. It's not a very challenging rule, but it does look a little bit intimidating for some people. So let me just first of all point out a couple things. The plus minus symbol we've seen before in the quadratic formulas in this problem. This also says plus minus. All that means is the sign is the same as it was. So if it's plus, it's plus. If it's minus, it's minus. All right? So this is the structure. This is the answer over here. Plus minus means whatever the sign is stays the same. This only says plus right here because it's always plus. Okay, so if I see a binomial squared, no matter what the signs are in here, I'm going to get a positive object, and either a plus or minus depending on the middle term. A is the first object, B is the second object. It's a binomial structure squared, and the first object says A squared. So that means I'm going to square A. What's 2 times 2?
4.
What's x times x?
X squared.
X squared. The second piece says plus or minus 2 times A times B. 2 is the number 2, just like the one you count when you count 1, 2, that one, that 2. It's a regular number 2, it's just part of the formula. A is whatever this is, and B is whatever that is. So, it says plus or minus, this says plus, so I'm going to write plus. Again, whatever the sign is in the problem is what goes right here. Then if I'm doing 2 times A times B, this 2 is part of the formula. This is A, this is B, right? 2 times 2 is 4, times 7 is 28, times x is 28x. And then the last thing says plus B squared. It doesn't say plus or minus, it says plus. It's always plus. So plus. And I'm just going to square B. What's 7 times 7? 49.
Why do, how's your B 28x?
How's this part? So this is the formula, 2AB, right? And this is structure A plus B. So this is the A and this is the B, right?
Yep.
So A is 2x, B is 7, and 2 is 2.
And that's automatically your B.
B is this number and A is this number every time.
I mean, it's 28 your B. Look in the equation.
28x is what 2AB is. But B isn't 28.
Okay.
Oh, you're thinking of A, B, and C like in the quadratic formula. Yeah, no. This is just a quadratic structure. This A and B are different A and B.
Okay.
It's not the same A and B we've been working with the quadratic formula. Sorry about that.
Okay.
Sorry, I didn't think about that. The book used A and B, and I just went with what the book said. I probably should use different letters, but yeah. So 4 is, like if we're doing a quadratic formula, A is 4, B is 28, C is 49. But the A and B here is just a basic generic structure. If it looks like that, something plus or minus something, could just as easily been J plus or minus K squared equals J squared plus or minus 2JK plus K squared. The letters we use don't matter over there, all right? Just whatever the first thing is represents J and the second thing is K, so you multiply them out, all right? Sorry about the confusion there. So, and again, simplify that, that's the answer, okay? And again, it's a time saver. It doesn't seem like a time saver, but it is. If you learn how to do it well, you'll be saving lots of time.